We're studying IGCSE physics, and in today's class, we will be talking about a few more things, as the agenda is. We'll be talking about types of uses of radioactivity. We'll look at Rutherford's experiment. About atoms, structure of atoms. And finally, we'll look at safety precautions. Let's start with Rutherford's experiment. Now, it's not that long, it's very basic. And I want you to start reading from here. Ayan, start from here.
Atoms are made up of few small objective to describe the experiments that have led to the nuclear model of the atom, a tiny nucleus surrounded by orbiting electrons. Atoms are made up of even smaller particles. From experimental evidence collected over the past 100 years, scientists have been able to develop and improve their models, descriptions of atoms and the particles in them.
Atoms and the particles in them, fine. There are two models. We have the Thomson plum pudding model, and we have Rutherford's nuclear model. Now, there are more models after this, but we'll not be going into that. Let's start with this one, the first one. Anas, read. Anas, can you hear me?
Yes.
Start reading Thomson's plum pudding model.
Okay. The electron was the first atomic particle to be discovered. It was identified by J.J. Thomson in 1890. The electron has a negative electric charge, so an atom with electrons in it must also contain positive charge to make it electrically neutral. Thomson suggested that an atom might be a sphere of positive charge with electrons rotated about inside it, rather like raisins in a pudding. This became known as the plum pudding model.
All right, so what he's saying is, first, before we look at Rutherford, we're looking at the structure or model of atom. Now, the first model we are seeing is Thomson, J.J. Thomson. Plum pudding model. Now, why do we call it plum pudding? We'll look at that in a second. Now, the first thing is, Ayan, I want you to read the highlighted part one more time.
Thomson suggested that an atom might be a sphere of positive charge with electrons dotted about inside it, rather like raisins in a pudding.
Raisins in a pudding, all right? Let's see. I'll show you a raisin. Let's look at this pudding. That's better. Now, this right here is what is a plum pudding. This is what it's called. This is what we're talking about. Well, this is not really an atom, obviously, but it's a dish. It's sweet. It's a dessert. A dish, a sweet, a dessert. Fine, we know that. But how does this have to do anything with the atom? Well, let's make an atom, and I'll see how this makes a difference. Now, the first thing to be discovered about the atoms are that the electrons exist. Well, no neutrons were discovered then. We only knew that atoms must have something positive and something negative as well, because they must cancel out. Because they must cancel out, because positive and negative makes neutral. They cancel out. You add these together, going to become neutral. Because we know that atoms are neutral. Atoms are neutral. So they must have positive and negative charge. Fine. But what Thomson suggested was that the atom looks to something like this: the positive neutron, positive proton, the nucleus. This is the nucleus, and it is positive. He said the nucleus is positive, and inside the positive nucleus we have these small charges which look like this inside the nucleus. These small negative charges. Now we must balance this out. So let's balance it. Let's say I have 1, 2, 3, or a big charge like this. And these negative charges are balancing out. Let's say 5. This is what Thompson suggested. Ayan, is that clear? Any questions? That we have a spherical nucleus, with positive and negative charges inside that nucleus, like this pudding right here. Any questions?
No, sir.
Now, if you look at this pudding, you'll realize that the raisins, these small raisins here, if I make it yellow, these small raisins inside this are like the electrons, are the negative charges. Let's say negative charge. All of these raisins, and this whole thing is my atom, which is positive. Fine, and inside this positive new atom, I have these raisins which are like negative. That's what the plum pudding means. This is what it looks like, but this is wrong actually. This is not accurate. Atoms are not like this. So that's how we get to the more accurate representation of an atom, which was given by Rutherford in his experiment about the structure of an atom. Now, what Rutherford gave was that atoms are actually positively charged. Fine. Okay, but electrons are not inside the atom, but around it. Well, now we know that is true. Electrons are around the atom, or they're orbiting the atom like this. In, let's say, something like this. This is what the atom looks like. And this is the nucleus is positive and it's much smaller. And around it, we have electrons like this, orbiting. Fine. So this is what we have. Electrons around in positive nucleus. Now, the thing you need to write over here is, how did he realize this? And how did he find all of this? That first we have a small nucleus, and that we have electrons orbiting nucleus, and that all of this thing is actually empty space. Now, I want you to write in your notebook the key points. Start from here. Write Rutherford's model of atom. And after that, write key features. The key features are 1. Look at the book right here. Now, I start reading first from here. The
above experiment was carried out in 1911 by Geiger and Marsden under the supervision of Ernest Rutherford. It produced results which could not be explained by the plum pudding model. The thin golden foil was bombarded with alpha particles, which are positively charged. Most passed straight through the golden atoms, but a few were repelled so strongly that they bounded back or were reflected through larger angles. Rutherford concluded that the atom must be largely empty space, with its positive charge and most of its mass concentrated in a tiny nucleus at the center. In his model, the much lighter electrons orbited the nucleus rather than like planets around the sun.
All right. Now that's about it. Let's see. Fine. Now what he realized was the key features are the atom is largely empty space. I'll give you the reason for this. The reason why he thought this, or why he concluded this. Let's say key conclusions. Reason for this is that alpha particles bombarded bombarding gold particles, gold atoms mostly pass through. Write this in your notebook and tell me when you're done. Passed straight through. Anas, are you writing?
Yes.
The reason for the second conclusion is that some alpha particles repelled very strongly, let's say deflected very strongly at large angles due to being repelled by positive nucleus. Very few. When you're done writing, tell me.
Sir, do we have to draw that?
No, you don't have to. Well, this is just for explaining to you what's happening. Fine. Now, when you're done writing, tell me. I'll explain the conclusions attached to diagram.
Oh,
So
I'm
you
done writing,
understand
sir.
what's happening. Done writing. All right. Now, over here, all you have to look at is that you have, let's say, a gold plate, right? Gold atoms. You have gold atoms, and on this gold atom, what you're doing is you're throwing alpha particles towards it. So let's say these are alpha particles which you're throwing on this atom right here. And after that, it comes out like this. Now, what we realize is, look, these alpha particles, what's happening really is gold atoms, a gold plate. These are alpha particles. Now, can you tell me the charge of alpha particles on us?
The charge for a particle or
Alpha particles. Alpha particles.
Negative charge.
Ayan, charge of alpha particles.
Yes, sir.
What is the charge of alpha particles?
Sir, it's +2.
+2. It's 2 protons and 2 neutrons. It has no electrons, 0 electrons. Okay. So please write this in your notebook. Alpha particle is basically 4, 2, and has 2 protons, 2 neutrons. So the charge is 2+.
There's also a detector around it, right?
Yeah, this is the screen. That's less important, Anna. So what is more important is the charge of an alpha particle is 2+. Is that clear? How much is it?
+2.
2 plus 2. Now you have the screen right here. Fine. Now what's happening is when this positive, so alpha particle is positive. We know that. All right. When this positive alpha particle is going and hitting the atoms, let's make an atom right here. If this is an atom and this is the electrons, these are the electrons around it. Fine. Now what really happens is when the alpha particle comes through it, let's make this as the alpha particle. Now if I bring this alpha particle right here, and it goes like this. Now tell me what happens when you bring two positive charges together.
It stays
They,
positive.
yeah, and so like charges or positive charges repel, right? And unlike charges attract. So if you bring together a positive charge with another positive charge, it's going to repel, right? Is that clear? If you bring close positive charges together, they're going to repel each other because like charges repel. So what will happen is when this car hits it, it will repel away somewhere. Is that clear? It will bounce off. On the other hand, let's say it comes near it, it will bounce off like this in some other direction. But if you bring, let's say, an electron near it, very close, it will stick to this because positive and negative charges attract. Ayan, any questions?
I know, sir.
So what we're seeing is when I bring this card through this, it's very difficult for it to hit the atom because it's very small. So it will go like this. Sometimes it will go like this with no let's say deflection happening. But sometimes, very few times, it will actually be very close to the atom and bounce off like this in 90 degrees. This much. So it will bounce off like this. Therefore, we realize since the atom is largely empty space and the nucleus is very tiny, it's almost this small. Okay, compared to the atom, the nucleus is very small. So if I throw some alpha particles at it, it has a very small chance of actually hitting the nucleus, and it passes through like this. That is why we see most of the alpha particles pass through straight, but some of them are deflected in like this. Some of them are deflected like this to the sides. Any questions? Most of them pass through directly right here.
No.
But some of them, only few of them, they hit the small tiny charge here and they are deflected like this. So this guy comes like this and it goes like this. Usually what happens is it goes straight through like this. Fine. Now we look at some faster questions. Before that, let's just look at the uses. Now write in your notebook uses of radioactivity. I start reading from here. Radioactive isotopes.
Radioactive isotopes are called radioisotopes or radionuclides. Some are produced artificially in a nuclear reactor when nuclei absorb neutrons or gamma radiation. For example, all natural cobalt is cobalt-59, which is stable. If cobalt-59 absorbs a neutron, it becomes cobalt-60, which is radioactive.
Radioactive. All right. Now these are the uses of radioisotopes. Now we realize that most of the atoms are stable, but some of them are not stable. They have more neutrons. So let's write over here. I think I've told you already why things are, let's say, not stable. The reason for atoms to not be stable. The reason could be too many neutrons or too few neutrons. Write this in your notebook and tell me when you're done. Isotopes of atoms. We need to know that. if let's say you have any atom, perhaps let's say hydrogen, it has, or let's say helium. Helium has 2 protons and 2 neutrons and 2 electrons. But if you change it, if you get another isotope or some other form of this atom, and we add, let's say, 200 neutrons to it. Now, obviously, having 200 neutrons will make it unstable, because 1 proton and 200 neutrons, that's not stable at all. So what happens is this atom will break down into 2 atoms that will give out the extra 198 neutrons, and will become stable and become this 2p, 2n, He again. So that is why atoms, let's say, break down or give out radioactive emissions, because they are not stable. Perhaps they have too many neutrons or too few neutrons. Any questions?
No, sir.
Ayan, any questions? Then let's finally look at the last thing. 2 seconds. Now, can you see the syllabus booklet on the screen? I want you to read this part. Ayan, start.
Core, state the effects of ionizing nuclear radiations on living things, including cell death, mutations, and cancer. Describe how radioactive materials are moved, used, and stored in a safe way.
All right, let's start with the first thing, which is let's see. Well, you don't really have uses of radioactivity in your syllabus anymore. You do have safety. Safety from precautions relating to radioactivity. Write this in your book. Start and write dangers. The dangers are cell death, mutations, and cancer. Last thing is, what are the precautions you can take? First thing is, reduce distance between living thing and radioactive sample. Finally, the next thing we look at is reduce exposure time. Third we have is keep away from body. Pick up with tongs and not bare hands. 5. Always store radioactive sample in lead container. Write all of these down. Tell me when you're done. Anas, any questions you can ask me? Anas?
No question.
No questions.
Wait, can you move that? I've read the heading.
Now the chapter is over. We'll start by looking at questions.
Okay.
Finish writing? Ayan, Anas?
I'm sorry, what's sir?
Finish writing. Have you finished writing?
Almost. Done, sir.
All right. Now, Ayan, do you know what? Ayan, do you know what do you say? The Rutherford experiment is? Do you know it now?
Yeah, I pretty much understood.
Pretty much, right? It basically says two things. Atoms have very small nucleus and that atoms are largely empty space. That's all you need to know. Let's get a question relating to that. And let's take your time, no worries. Ayan, try to solve the question on the board. Write the answer in the chat. Anas, tell me when you're done writing. Anas, you can talk. It doesn't make a difference if it's noisy or not. All right.
Okay.
Now let's look at the question. Anas, read the question.
A very important experiment increased scientists' understanding of the structure of matter. In the experiment, particles scattered as they passed through a thin metal foil. Which particles were used and to which conclusion did the experiment lead?
All right, Anas, answer. Ayan in the chat.
I think B.
B.
Yes.
B is correct. Good guess. Next question. Now, Anas, Ayan, read the question.
The arrangement is shown is used to check whether the floor inside a cardboard packet is above a certain level. If it is above the level, the flower absorbs the radiation from the source so that it doesn't reach the detector. Which type of radiation is suitable to use?
So what are we trying to do here? We have a container, and inside this we have some substance, perhaps flour. And the purpose of this is, if you have enough flour inside it, then the radioactivity which you pass through into it, let's say like this, is not going to come from the other side. It will be stopped. This will not happen. So what kind of substance can I use so that it will be stopped by flow? Alpha particles. Okay, all right. What else? Now this, okay, you gave alpha particles, but that's the wrong answer. Why? Because alpha particles will always be stopped. Now I want this to stop only when there is more than a certain level of flow. Perhaps when, okay, I'll give you two options here. So when I have this much flow, okay, this much flow, then it should not stop. But when I have this much flow, then it should stop. So what do you think is the correct answer then? Now alpha particle will always be stopped. If I had an alpha particle, it will be stopped when there's less. It's stopped by paper. So it won't really work in this case because it will always be stopped. I want my radioactive particle to only stop when there's too much flow and not stop when there's little flow. So tell me, what else can I have? So I have beta particles, which are stopped by aluminium, thin aluminium. And then I have the last option, gamma, which is never stopped. Ion, which is the correct option then?
Alpha and beta.
Alpha and beta. Now we can only use one type. That's the question. We can't use both. It's an or option. So you have either this or this, but you have to choose one. The alpha is always stopped by anything like paper, but beta is only stopped by thin aluminum, and gamma is never stopped unless, or let's say, unless with lead, except lead. So the correct option in this case is going to be beta particles. Why is that? Because beta will not be stopped with a very less flow. Alpha will be stopped. Alpha will be stopped with both, so that it doesn't help me. But beta will be stopped with less flow, and when I have too much flow inside it, it will be stopped. So it passes through when little flow, and there's too much flow, then it stops. So alpha is beta is the correct option. If I took gamma, then gamma will not stop with both of these because flow can't stop gamma. So the correct option is alpha beta particles. Is that clear, Ayan? Ananas?
Yep.
Yes, sir.
I want something that is stopped in one cases, but not both. Well, gamma never stops, alpha always stops. So beta is the correct option. Now, next one. Read the question, Anas.
Okay, so below are 4 statements about isotopes of a certain element. Which statement about the isotopes must be correct?
Must be correct. Okay, tell me. Answer, Ayan.
A.
Ananas. A. Must be correct. A. Okay, that's Anas' answer. What about Ayan? What do you think?
So yeah, sorry, I think it's A2.
First, A2. All right. Now, can someone define what is an isotope?
Wait, no,
Define
sorry.
isotope.
It should be D.
B or D?
D.
This one?
Yes.
The isotope is basically an atom or atoms with same number of protons but different number of neutrons. That's the definition. Now the definition has nothing about radioactivity. So we realize that these two conditions must be same number of protons or must be true, or different number of neutrons. So well, this cannot be the answer. This cannot be the answer. They have same number of neutrons. No, it must be different number of neutrons. So then this is wrong.
Oh, okay.
This is wrong and same. That's correct. Fine. This is the correct option. Next one. Question 4. Ayan, read the question.
A nucleus of americium 24395 emits a alpha particle to form a nucleus of neptunium. Which equation represents this decay?
All right. First, tell me what is what are the components of an alpha particle? What is the structure? What do you have in it? What is alpha particle?
Alpha particles are positively charged, like 4 and 2.
4 and 2. So 2. So it's
So wait,
4
4 is the
above, 2
proton,
below.
right?
4 is the nucleon number. Nucleon. Everything
nucleon,
inside
okay.
the nucleus. And 2 is the
Okay.
proton number.
Okay.
So it must be 2 proton and 2 neutron. So 2 plus 2 both are inside the nucleus. So 2 neutron, 2 proton, that means 4. Okay, because this is equals to P plus N and this is equals to P only. Any questions? And the charge is 2
No.
plus. Now over here, let's see what could be the case. How do I represent this? Now I have 243, 95. The nucleons are 243, protons are 95, AM. This is breaking down to give us NM, NP. Well, I don't know what this is because I won't be getting a periodic table because this is not chemistry. And next thing is, I do know that alpha particles are released and they have 4 and 2. Fine. So I know there's one more thing I know that is that the top part must be equal. All of this must be equal. And the bottom part must be equal. So can I form two equations here? Two equations could be 243 plus is equals to x plus 4 and 95 is equals to y plus 2. So quick, tell me what is x and y.
Okay, so for x we're going to do 243 minus 4.
So 239.
So yep, and for 95 we're going to do minus 2, so 93.
So it should be D.
93. The option is, well, 96, that's wrong. 97, that's wrong. Well, alpha particle is obviously not this. It's not 0 minus 1. It's always 4, 2. Now, between these options, I have two choices, 47, 97 or 23993. So this is the correct option. Wrong? Correct option. Right. Anas, any doubts? Ayan? But I think it's easy now, right?
Yep.
Now this one. Question, I think 5. Anas, read the question. Ayan, answer.
Okay, below are the symbols for 5 different nuclides. Which 2 nuclides are isotopes of same element?
Okay.
Aren't
Quickly
they
tell me,
all the
Anas.
same like the
Anas,
X?
what is isotope? What is an isotope?
Isotope is an atom with same number of protons but different number of neutrons.
Okay. So therefore, the proton number must be same, right? And
Yes,
I know the
so
number below is P.
1 and
So which
2
of these
are
have
same.
same?
One and
Same
2.
proton. And everything else is not same. So the correct
Different.
answer is
A.
A. Easy, right? Ayan, any questions?
No, sir.
Question number 6. Quick, now you should hurry up, because the more questions you can solve, the easier it will be. Now, all of these questions are from 2016. Start. I read the question and answer.
Which diagram represents an experiment that provided evidence to the nuclear atom? Alpha particle going to gold nucleus, beta particle gold nucleus, alpha particle above a gold nucleus,
Gold
and beta
nucleus,
particle
right.
above a gold nucleus.
So which of these is correct? What do you think, Anas?
Sir,
And
it's
yes,
A.
it is A. All right, that's Ayan's answer. Anas, your answer? B. Now I'll show you the diagram which I drew for you. Let's see. Now this is the gold nucleus, and this is what we had. That the gold alpha particle came like this, okay, and it deflected from the positive nucleus, because positive repel, right? If you bring two positives together, they will repel. And this is what happened. It deflected almost 90 degrees like this. Well, on the other hand, if something was very if it did not hit if it did not hit the nucleus, then it went straight forward like this. But this is the key, let's say, observation. That the key observation is alpha particles bombarding gold atoms. Few alpha particles deflected very strongly at large angles. Deflected large angles. Let's see which of these must be correct now. Therefore, the only correct option I see here, well, we did not use beta particles, so that's wrong, right? We used alpha particles on us. So, well, these two options are wrong there. Now, between this and this, which has to be the correct one? Well, I realize over here that this one must be positive. The nucleus is positive. And if the nucleus is positive, let's say, then alpha particle is also positive. That will not be attracted like this case, it's attracted. So that means this is wrong. And over here it's deflected. And what we realize is the alpha particles are not attracted but deflected, since like charge repel. Any questions?
No, sir.
Because both of them are positive, and I didn't use beta particles, I used alpha, and alpha positive repel. That is the big thing that happened. So correct option is C. This one, read. Anas.
Okay, a radioactive decay can be represented as shown. The equation is complete. In this decay, the nucleus changes by
How? Equation is incomplete. What is happening in this case? Tell me.
Are these two isotopes?
No, not isotopes. It's an equation.
Okay, so
radioactive
so
decay is taking place. Yeah. And it's incomplete. I have to add something over here. Three kinds of atoms.
I'll go
Alpha,
with B.
B. Okay. Ayan. Now, Anas, can you give me any reason for your option?
Because PA has like 91 protons, and U has only 92. So PA needs one more. Yes.
I see. All right. One more. So I think you think that it got one, right? Okay. Absorbing. Makes sense. All right. Ayan, your option.
Sir, it should be A, right?
A. All right. A. Ayan. Now I'll say both of these are wrong. Now think. Now decay always happens by these things, either alpha, either beta, or gamma. Nothing else. Right? You don't have any option about proton or neutron being absorbed. Not in these questions. When they will ask you, it will only be for this guy. Neutron will only be for fission and fusion. This is clearly not about fission or fusion. They will say that in the question. Fission or fusion. But this question is already active decay. Now, okay, this is what we have. Now, please quickly write this in your notebook. All right, look, write this in your notebook. We have two kinds of alpha particles. Write, just a second. Take all of this, these four symbols, and write them in your notebook. Tell me when you're done. Write it as types of decay.
Okay.
And this is called alpha. And I'll tell you what's happening in all of these. This is called beta, and this is called gamma. Now, but what happens in this? How does this occur? What causes this? Now, you need to realize that alpha is basically 2p and 2n, let's say, lost. Okay, over here, energy lost. Let's say released. Write this in your notebook. He, helium nucleus, released. Because helium nucleus is He4 2 plus. Write this as well. Or write it like this. He4 2 plus. Over here in gamma, energy is released. But it's quite interesting about beta particles because you have two types of them. You have beta minus and beta positive. Let's first talk about beta negative. Then we look at 0 plus 1 beta. Now in this, what's happening is, let's say in this, neutron turns into proton and releases negative charge. Write this, tell me when you're done. And in this one, you have proton turns into neutron and releases positive charge. Now, what else do you need to know here? Well, one more thing you need to know in both of these is that nucleon number is constant. Nucleon number is constant. How much have you written, Anas? Manvi, can you hear me?
Yes.
Have you done the types of beta decay in school?
No, I mean, we did beta decay, but we didn't do types of it. It's just one proton one neutron turns into a proton, right?
Yes,
And
neutron turns
one
into it.
electron is removed.
Electron is removed. There's also beta positive decay. Have you
Oh.
done that?
No.
All right. You should look into it. Check for beta positive decay, and in that a positron is released. It should be in your book. Sometimes, usually the questions are asked. Now, Manvi, I'll start the class. This is 2 minutes. All right, I'll add you back.
Sure.
Anas, I am done writing.
Yep.
Now you need to memorize this whole thing. You have to memorize it by heart. Now let's look over here. In beta decay, nuclear number is constant. Fine. Nuclear number is constant. Now, one more thing. In gamma decay, both nucleon and proton number are constant. Ayan, how much have you written?
I'm on the last line, sir.
Anas, write the last line. Now, with this information, I think you can solve the question. Write the last line as well. Finished?
Johnson.
Anas?
Yep.
Now look at the question. In the question, what we realize is, let's forget all of what's happening here. Let's look at the question. What we realize in the question is that the nuclear number is constant. Okay, if nuclear number is constant, therefore it cannot be alpha emission. It cannot be alpha decay. So alpha decay is out of the question. Alpha decay, 2 protons and 2 neutrons are lost. So therefore, this will decrease by 2. The first one will decrease by 4, and the bottom will decrease by 2. But that's not happening here. On the other hand, it's actually increasing. So alpha is not the option. Fine. Then, well, proton number is changing, but in gamma, proton number does not change. Both are constant, so this cannot be the option. Now we have beta particle only. Okay. What's happening here is proton number is increasing by how much? We're getting 1 more proton, right? Is that clear? How many protons are we getting extra? Mic's on. How many protons are we getting extra? 1. So in this case, what happens is that a neutron turns into proton. Write one more thing. Proton number increases by 1. Proton number decreases by 1. Guys, can you hear me?
Yep.
Yes, sir.
Write the last 2 lines. Proton number increases by 1 and proton number decreases by 1. Now in the question we have the proton number is increasing by 1. Therefore, the only possibility I have is this guy. Beta negative. First, or beta emission. It can't be alpha, it can't be gamma. Therefore, the correct option is D. Because proton number increases by 1. Finish writing. Now, after you finish writing, underline
done,
this
sir.
part as well. Well, that's enough. Now look at this. Yeah, you're going from 233. So this is same. And one more proton. Therefore, the only possibility I have is this is the equation I'll get. Beta 0 minus 1. Now, Anas, if I add 92 and minus 1, what do I get?
Wait, can you repeat?
If I add 92 and minus 1, what will I get? Look, this is the equation we get. For the bottom over here, we get the equation 91 must be equal to
Wait,
92.
91 plus
minus-
91 plus 91. Oh, 92 minus 1. Okay.
So I'll get 91. So therefore, my equation is correct. And on the top, 233 is equals to 233 plus 0. So therefore, again, the equation is correct. The only option I have is beta negative 0 minus 1. Anas, any questions? Ayan, any questions?
No.
We'll end the class right here. Now, just do one last thing. Add a symbol like this in front of this. Fine, because this is the important one. We're studying IGCSE maths and we're looking at a difficult question, which was in May, June, S 2022, May, June 2022, QP 43. Question number 10. 9, question 9. This one. Let's see. Now, the first thing they're asking us is to sketch the graph of this, right? X plus 1, 3 minus x, x plus 3. What we realize is, what are the square roots of this function? The roots are going to be can you tell me, Manvi, if I have a function like this and I make this, say that again?
Was this like a differentiation question from in the exam?
Yes, it was.
If
Now, when I
you,
make this equals to 0,
factorize, okay.
and then I
you-
realize
you-
that x is equals to x plus 1 is equals to 0,
Yeah,
or
so
3 minus x is equal to 0, or 3 plus x equals to 0.
yeah,
So that's what I have in this. Now, therefore, I can say that x is equals to 0. No, not 0. This is
1
minus 1,
minus 1.
or I have 3, or minus 3. So the graph must pass through these points. Let's say it's a sketch, so you don't have to show the axes. All you have to show is the points. So minus 1, minus 3, and 3. Now we can make two kinds of graphs, something like this. Right? Or something like this. Both of these are correct. Any questions?
No, that's it.
That's it.
Oh, I did the second derivative and the first derivative.
No, it's a sketch. It's a sketch. You don't have to do that right here. Right?
Okay.
Now let's look at the next step.
This is easy. You just have to open the brackets.
Yeah, so you need to be aware. You need to be aware of what kind of question they're asking or what the question means. What they're asking you. They're asking for a sketch. And we know that since these are the three, it must look like this, right?
Oh,
It cannot look any other way because it has to pass through 3 points. It must intersect the graph at 3 points. Now let's see. You can show this. It can be written as this, right? So let's open the brackets. X plus 1, 3 minus x, 3 plus x. Fine. Now open the brackets. If I'm going to open the bracket to look something like this, perhaps first let's open this up. So we'll get the first two. We'll get x 3x plus 3 minus x squared and minus x.
Yeah, if you simplify everything, you get y is equal to 9 plus 9x.
That's what we have to show, right?
Yeah.
So now let's simplify this first. We'll get
9x
minus x squared plus, we'll look at that in a second. Let's first simplify the bracket here. So this bracket will be 3x minus x, 2x. Minus x squared plus 2x plus 3. Now let's multiply this again. Anas, please open your mind and focus completely and ask me if you have any questions at all. Right? I don't mind.
Okay.
Next, we're multiplying all of this with this and this. Then this with this, then this with this. Both of these.
Okay.
Let's first start with minus x multiplied with both of them. So we'll get minus x squared. We'll get minus 3x squared. Minus x cubed. Done. Then let's look at the next one.
Plus 6x plus 2x squared.
Plus 6x plus 2x squared. And let's look at the third one.
Plus 9 plus 3x.
Plus 9 plus 3x. Now add all of these together. What will you get?
9 plus
Well,
9x
minus 3x.
minus.
Let's keep the minus 3x cubed first. And then let's always start from the highest power. Then
Okay, so minus x squared. Minus x squared.
Plus 9x.
Plus 9x plus 9.
Done.
Yeah.
So therefore, we'll say therefore y is equals to, we'll just say therefore y is equals to, so hence proven. You don't have to write this, it's just my habit. Done. Next, that's done. Which question? The next part of the question, right? Let's see.
Yeah.
So you may realize the first two questions are not that complicated. You just have to open the bracket and find the roots.
Yeah.
And this one, you have solution. The solution for this is going to be, you have this equation and you have to find all the turning points. Turning points are also called stationary points. And as what are turning points?
Okay.
Stationary points.
Stationary points is like when it says 0, 0.
No,
Or
it's
not.
not the 0, 0. dy by dx is equal to 0.
Oh,
Fine. Now, please, we have done this already, but whatever I say now, write it in your notebook. And as I think you should write the solution in your notebook while I'm writing it on the board. Both of you. Now, dy by dx will be, first, let's say what was y? Y was 9 plus 9x. I like to rewrite the question on the page just one, so I have a good feeling of what the question is. Then I'll start manipulating it to get the answer. Now 9 will become 0, fine. 9x will be 9. Minus 2x squared will be minus 2x. And minus 3x will be minus 3x squared.
Minus 3x squared, yeah.
Now our job is to see, okay, therefore, stationary points.
Stationary points is equal to, is when dy by dx is equal to 0.
At dy by dx is equal to 0. Or when dy by dx is equal to 0. Fine. So we'll write this as minus 3x squared minus 2x plus 9 is equal to 0. Let's use the calculator right here. Or you can use the quadratic equation as well, but just give me 1 second.
So are we
let's use the
supposed to
quadratic.
show all of our working, right? Yeah.
Now, actually, show all your working. I'll tell you how to show the working and use the calculator. Fine. Now, since this is IGCSE, it's not A levels. They don't really care. They do care about working. I can't tell you that as a teacher. As your teacher, I'm going to tell you that you have to show all the working. Yes. So we'll write this minus b plus minus b square minus 4ac divided by 2a. What is b? It's 7 marks. So yes, let's show all the right things, right? 7 marks.
I was doing the
Minus
same thing.
3. So minus b will be minus of minus 2 plus minus b squared minus 2 whole square plus 4 minus 3, 9. Any questions on us?
Nope.
Nope. All right. That's a very big nope. So I'll give you a question like this afterwards. Now, minus 3 over here. Now, when I simplify this, I should get my answer.
Yeah, I'm doing it.
So this will be 2. And so 2 square is 4. 4 plus minus 12 into 9. 9, that's going to be 120. 108. So this is going to be minus 108, which will be minus 104 divided by minus 6. Therefore, the two options I have is 2 plus minus. There can't be minus, can it be?
It's not 104. It's 10. It's 4 minus 108. So that's 112.
Give me 1 second. The equation they have here is minus 1. All right, it's not plus 4. It should be minus 4, obviously. Right. Fine. So we had 4 plus minus 4 plus 108, which is 105 divided by minus 6. So two answers are 4 plus 112 by minus 6 or 4 minus 112 by minus 6. So therefore, let's use our calculator to check the answers if we are correct or not. Minus 3, minus 2, and 9. The answers are if you divide all of them by
1 second. One of them is minus 2.097.
yes, so it has to be this one. 097, right? That's what you're saying. And the other
Yeah.
one is
The first one, and then 1 second, I'm doing it.
minus 1, which is going to be 1.4.
1.43. Yeah.
1. Now, okay, you got your answers as 3, 4 SF perhaps, right?
Yeah.
Both are fine, but I would prefer if you give your answer as 3 SF. So,
Yeah.
which is the same as
But I
1.43.
thought I would let it be till the final answer. Do we have anything more we need to solve in this question?
That's done. No, that's it.
Okay.
2.10. That's the answer. Any doubts?
No. What is
Yes, Anas?
K? What is A and what is B in the next question?
Okay, they're telling us the equation is this, has only one solution when k is smaller than a and when k is bigger than b. Wait, okay, that's quite easy, right? Look, I'll tell you how to solve this. Let's write an equation first. X cubed minus x squared plus 9x is equals to plus 9 is equals to k. Now it has only one solution in the range that k must be greater or smaller than a. K must be smaller than a, or k must be greater than b. Fine. That must be our answer. Now what we realize is, okay, can I do this, Manvi? All I have to do is, it's the same equation from the beginning, yes? 9 plus 9x, yes, same equation. All right. Now all I have to do is, I have to take this x cubed, x squared plus 9x plus 9 minus 2. That's what I have to do, is equals to 0. Now, can I do one thing? Can I say as a solution? Now they had factorized this for us already. Let's look at the factorized format. Factorized format is given in the first question, I think. X plus 1, 3 minus x, 3 plus x, x plus 1, x plus 1, 3 minus x, and 3 plus x
Plus
equals to k. As only one solution. All right. Now our job here is to realize that since it only has one solution, okay, I think we don't need to do this part, but we have to take that. And they've given us the stationary points here. All right. Okay.
How are we supposed to solve this?
So do we know what A and B are?
No, that's what we're trying to find. Just give me 1 second, right? Now, give me 1 second. Meanwhile, Manvi, let me record again. All right. So we have the equation here. They've given us the equation already. Let's remove all of this. This. Now they've given us the equation. Fine. Now our job is to find out that if all of this is equal to k, and they're telling us k is smaller than a, or k is greater than b. Fine. Then let's say k is smaller than a. Can I write this like this? X plus 1, x 3 minus x, and 3 plus x is also smaller than a. Can I do that?
Okay.
Yeah.
Now the next thing is I have to realize what are the possible solutions.
Okay.
Now to find the possible solutions, well, I think we have to take it to the other side actually. Let's write this. It's more than 0. Okay. And now all we have to see
So
is
9. Okay, 9. Minus 9. We're taking 9 to the other side.
we're not taking, it's not 9, it's a. We're taking a to the other side. It's smaller than a. It's not 9. A.
Oh no, I'm talking about
Fine.
the third step. We're supposed to
Third
take the constant to the other side, right? Which is 9.
But it won't work like that. All right. It doesn't work like that. Now, okay, next thing we can do is from this step, you have to substitute some values inside it. Let's try with one substitution. Let's say you have, let's start with by trial and error. All right. Now, let's start with, let's say, let x equals to, I'm going to start with 10. Fine. How much?
10.
10. Now, when I put minus 10 inside it, this power cube minus,
So that's 1000 minus 1000.
yes. And we just have to see if it gives us an answer or not.
Minus 100 plus 90 plus 9 minus 8 is greater than 0, which is equal to minus 1001 minus 8 is greater than 0.
All right. Now, since we already know since we already know that the x values we found were, what were the x values we found?
They
Minus
were
1, 3, or
minus 2.097
No,
and
this
minus.
that's the stationary point, all right?
Oh, okay.
This one, look. These are the solutions to the graph. Minus 1, 3, or minus. That's where it passes through the x-axis, right?
Yeah.
Let's go over it. What were they? Minus 1, or
So we're just substituting these.
yes. Now, or 3 or plus 3. These are the possible solutions we had already.
So I feel
Correct.
like it will be plus 3 minus 3.
Say that again.
I feel like
Now,
the
all you
answer
have to do
going
is, yeah, I'll tell you what the answer is. Let's first start with minus 1. Okay. Now, when I put minus 1 inside, it's clearly, I think there's something missing. You'll have to give me some time on this, all right?
So that 0
I
is
can-
greater than A. Sorry, A is greater than 0.
A is greater than 0, not really 0. Is yeah, A is greater than 0. Fine. Do one thing. I'm going to get back to you on this, fine? Because I want to do
Yeah.
a few things which will confuse you right now, and it will actually waste your time. Okay. There's
Yeah.
something I think I'm missing as well. It's not that difficult. It's only a 3-mark question. So what I'm thinking in my mind right now is not to make it difficult for you.
Yeah.
And what will be the catch in this question? Fine. So tell me the next question you have.
1 second. It's question 7D.
Question 7D.
D for donkey.
All right. D for donkey. All right. Because I'm quite sure if I do it on the paper, it will be much simpler for me. Right, so I'll send you the answer right after class. Look at this. Next question. Question number 7. Which part? D.
Wait, is this vectors?
This
I mean,
is angle properties,
Oh, angle properties.
not vectors. Now we're not doing that. We're just going through some rough questions. Now look at this one. Okay, has area as this much. Same area, possible values of angle PQR. Okay. ABC. Let's call this PQR. And has the
Yeah.
dimensions 90 and 60. 90 and 60. And the area over here is how much?
So
Area is same as ABC. What was the area of ABC?
the area
Did
of
they give
ABC,
us-
I don't remember.
You don't know. Then let's find it from here. Area is always for a triangle,
But AB cos C by 2.
half AB sine C,
Yeah.
not cos.
Okay.
Right? Half AB sine C. You should memorize it like this. Now, okay, therefore the area, let's find it. Area of triangle is half A is 82, 52, 55 into sine 76.
Yeah, I'm doing it.
What is the answer? Anas,
1
find the
second.
area of the first triangle ABC. Quick,
AB.
please.
So it's
How do we do it? Yeah, tell me.
That's the thing we do. 1/2 into 82 into 55 into sine 76.
Okay, I'm getting
Now,
the
do you know why?
value to 188.02.
Now, Anas, do you know why we do this?
Zero
Because
to
whenever
zero.
you have a triangle, you use this formula. Write this in your notebook, Anas. Any questions? Whenever you have a triangle, you have to use this formula and the angle between the sides A and B. Now we'll use the same thing here, half AB sine C. Just give me 1 second, I'll check if this is correct. 82 times 55 into sine 76. 288, yeah, correct. Okay. Now we know that the area is same, so 2188.02 is equals to half AB sine C. Now A and B, I know that it's 90 and 60. 90 and 60. Right, Manway? Write the answer in your notebook, all of you, both of you. The exact steps which I'm using. Now, next thing you have to do is find sine, what is C? Angle C. Let's first take all of this to the other side. It will become 2188.02 divided by 90 into 60 is equal to sine C. Now simplify this, tell me the answer.
So 90 into 60, right? Wait, 2 into 188 divided by 19. Okay. So it's 3SF, right? So 082 or 0810.
0810. But okay, that's 3SF, that's correct. But on us, this is not the final answer, right? We're in calculation right now, so you have to give 5SF. Clear? Or more values, as many as you want, let's say 5SF or 6SF, 5 digits, more values. When you give the final answer, that's when you do all the rounding. Now sine C. Now to find sine C, all I have to do is take sine to the other side, yes, Anas? Right? And then I'll inverse it, sine inverse of 0.81038. So what is C?
So you do sine inverse and then do answer.
Answer, yes.
Or you could just write answer.
Yeah, you could just write answer.
So it's 54.9.
Which is?
4.
How much?
54.14.
54.1.
Okay, yeah.
Now they're telling us give 2 possible values of angle base.
Yeah, that's what my question was. So are we supposed to add and subtract 180? Because I have a friend who got this correctly, and I asked her, and then she said she added and subtracted 180 or something.
Right. Now, now since I know this, right? Now you know the graph for sine. Graph for sine looks like this.
Yeah.
So first let's write the intervals. I've told you Anas this already. We did a class on this. Now we have pi, let's say 90 degrees, then 180, then 270, and 360.
Sine 90 is 1. Sine
Right. It's always like
180
this.
is
Look.
0.
Now these are our reference values. Okay, the domain and the range. The y values are the range, the x values are the domain. Now this is going to be 1 here, and 0 here, 0 here, 1
Minus
here, and 0.
1. Yeah.
This is what your graph looks like. Fine. Now I found 54.1, which is somewhere, let's say here.
Yeah.
So when I make a line like this, I'll get the x value as, y value as how much? 0.81. What I got right here.
Yeah.
Now, if I make the line go forward like this, I'll reach another answer. which is this.
Oh,
Now, what is this answer? Now, I'll give you a trick, a method. Please write in your notebook.
yeah.
Finding, write it like this: finding multiple angles. This is in class 11. A big deal in class 11, right? Finding multiple angles in sine trig graphs, trigonometric trig graphs, or trig functions. Now let's start with sine first. For sine and cos, you can do two things. You have to do this. 180. First, you have to find the answer. So first step is find one angle, one answer, one angle. Second step is 180. 180 plus theta equals second answer. Right? And there's one more you can do. Well, no, that's all you can do for sine graphs, actually. Just a second. Let's get this. Let's look at cos now. For cos graphs, you find one angle again, and all you have to do is, I think,
Are we supposed to memorize the trigonometry, the tan graph as well?
yes, you have to do that. Tan graph as well. Now I'll give you a very clear thing right here. Just a second. Make this table first. Before you do any of this, make this table. And memorize it by heart. Now, this is very rare and it will come, but it's not that common. But write this. The first thing is you have 90, 180. Make this table and write these values.
Okay.
Now you have plus, write all.
So like a proper
Yes.
table, right?
Proper table like this. What I'm doing on the board. Arrange like this. Okay. All sine, tan, cos. Write this one. Tell me when you're done.
Okay, done.
Okay. Now, fine. Now our job is to look. I'm also going to show you the graphs we have. So we have the cos graph, which looks like this. Right? This is what the cos graph looks like. And the last thing we have is the tan graph, which looks like this. Fine. Any questions? Well, we know this already, that the tan graph looks like this, and sine looks like that, cos looks like that. Make all of these graphs in your notebook as well. The sine graph, the cos graph, and the tan graph. Tell me when you're done.
Sort of.
Now it never touches 90. It never touches 270. Okay. And it never
Yeah.
touches, that we know that already. And backwards it will be in minus 90.
Yeah.
It never touches any of this. Anas, talk to me. Are you making the graphs? Any questions?
No, no questions. I think I have this. We did
You
this.
have this already in your notebook. But
Yeah.
make it again, make it one more time. Now for the sine graph, you should make it, but don't make those lines, right? Don't write 0.81 or 54.1.
What is this?
I'll tell you what that is. Finish making the graphs and writing the table, right? This one.
Yeah, done.
Done. Now just write below this table as a note like this. When are trig values of trig functions positive? Now for sine is positive in the first. All of them are positive in from 0 to 90. From 0 to 90, all of them are positive. Look, sine is above the graph. Cos is also above the graph right here. It's positive. And tan in 0 to 90 is also above the line right here.
Yeah.
All of them are positive. But for 90 to 180, cos is below the graph, so it's negative. Tan is also below the graph, so it's negative. But sine is again positive. So sine is only the one positive from 90 to 180. The rest are negative. Fine.
Yeah.
Again, from 180 to 270, sine is only tan is positive, everything else is negative. Tan 180 to 270 is going above, but cos is below, and sine is also below. So negative. Next thing we need to realize is from 270 to 360, only cos is positive, everyone else is negative. Fine. Now below, just below this, write this as well. Sine.
I'm gonna be
Yes,
right back.
Anas.
Be right back.
All right. Make this table as well.
Yeah.
This will also help you remember the shape of the graphs, because the shapes are exactly the similar, exactly same, but the loop for sine is positive here, but and then again positive here like this, but cos starts right here and looks like this.
I'm back.
Okay, done.
Done. Now next thing you have to do is below this, just write this. Alternate answers. Equals to alternate answers, then write 360 or let's say 180 plus minus theta 1 gives us theta 2, which is our alternate answer. Or 360 plus minus theta 1 gives us theta 2, which is my alternate answer. Now both of these can give me alternate answers. All right. Now tell me when you're done writing this.
Done.
Done. Okay.
1 second.
180 plus theta, if let's say if all right, Manvi, look over here. Let's say one of my graph, it looks like this. Okay, this is my graph. Which graph is this?
This is sine.
Sine. Now I have one value here. Okay, that's one answer, which is let's say theta 1. Now how can I find another theta? Another theta 2.
Plus 180.
Plus 180 will give me right here. this one. So if I go 180 ahead, I'll reach right here. Now, but you realize there's a problem here. Theta 1 gives me a positive answer, while this theta 2 gives me a negative answer, right?
Yeah.
So since I want a positive answer, I won't do theta 1 plus 180. I'm going to do 180 minus theta 1. 180, I'll do this one. Because I know that I'm looking for an answer over here. My answer must be right here.
Yeah.
So for this, all I have to do is I have to go back theta 1 times to reach this place, which is theta 2.
Okay.
Does that make sense to you?
Yeah.
All right, thank God. Good.
Mhm.
Now, okay. Next thing we have is, now if I tell you Manve, on this graph, one of my answers is not here. Perhaps if it is, let's say here. And I'm looking for the next answer. So theta 1 is between 180 to 270, and I'm looking for the next answer. What do I have to do?
Theta 1, okay, you have to do plus 360 minus theta 1.
Exactly, that will give me theta 2, right? Now this is the general solution. If I just told you just do 180 minus theta, you will have no clue why you're doing it, right? Now do you
Yeah.
understand why we are doing this? And I've given you one more option, 360. Now in the exam, if you had gotten an answer, perhaps let's say 200 degrees, and they asked you for the second answer, and if you did 180 minus 200, that would have been wrong, obviously. So your friend told you to just do 180 plus, but that's not correct. The correct thing is to find the next option. All you have to see is if my sign is negative, where else is sign negative? Okay, it's between 270 and 360. To reach there, I just have to do 360 minus theta 1. Does that make sense?
Yes.
Now, if I give you one more, let's now look at cos values. If I make the graph of cos, which looks like this, one of my answers is here. How do I find the other answer?
Yeah. Minus, okay, plus 270 minus theta.
But the issue is, I don't have the option of 270, do I? There's only 360 or 180. We can't do 270 or 90. So how will you reach here?
360 minus theta.
But that will give me this place, which is the
360
opposite one.
minus 360 minus theta minus 1 second. The difference minus 90.
360, say that again.
360 minus 90 minus theta.
All we have to do, Manve, is 180 plus theta. And we'll get our
okay.
answer right here. Fine?
Yeah.
Or actually, now we have to do 360 minus 360 minus 180. Not 180, theta 1. Okay, if I give you one more option, let's say the second option is this one. Your answer is right here, theta 1. How do I find the other option?
You subtract no. You add plus 360.
Then that would give me an answer right here.
Okay, so you
That would be correct.
360 minus theta.
So I have 3 possible answers for this, right?
Yeah.
All of these are correct. But in the domain, you must only get an answer from 0 to 360, not more than 360.
Yeah.
They don't accept it, right? Because I think they've given it here. No, they have not. So you can give any answer. You can do 360 plus or minus. But you need to make sure that if you look, if the theta here gives a positive value, the next theta must also give a positive value. Is that clear?
Yeah.
Now let's just do last one for tan. If my answer is right here, let's say theta 1, how can I get the other answer?
Plus 180.
That's 180. Now the trick over here is it's always going to be usually plus or minus 180. You can also do plus 360. So now you understand how to do it, right?
Yeah.
So
Yeah.
there's a formula to this. It's just how you must understand what's happening.
Yeah.
So you can do plus 360, or after this you can even do 360. We have 540 plus 540. You'll get another answer over here, right? All of those are correct. But in the exam, you don't have to go that far. All you have to do is make sure, check if it's 180 or it's either 180 minus theta or 180 plus theta or 360 minus theta or 360 plus theta. That's it. Fine. Have you written everything?
Yeah.
All right.
Yep.
All right. Then that's all for now. Please, Anas, finish the vector 2 worksheet. Have you done it?
No,
Now, when will you do it?
I'll do it by Saturday because I also have holiday homework to do.
What homework do you have? Tell me.
Holiday homework like from school.
Holiday homework from school. But the issue is, I am preparing you for the final exams, right? And
Yeah.
you're clearly behind everyone, which is not a problem, but it will be a problem if you don't study and finish more work, because you have to work harder than the others. Unless you understand.
Yeah.
And I know you're working very hard, so that's good. But you have to work harder than the others to get the same marks, because you're behind. If you work harder than others, you'll get the same marks as everyone. All right, at least you'll catch up. Then you'll be getting the full marks. Clear? So I want the worksheet done by tomorrow. Is that clear?
Wait, which
Anas,
one?
vectors 2.
I don't think I'll be able to do it by today.
Not today, by tomorrow night. All right.
Oh, okay. Tomorrow is good.
Manvi, worksheet 2 from tomorrow night. All right. Until tomorrow night. Vector 2.
Oh, okay.
It should be
Yeah.
in GCR in my office, and I should be checking it tomorrow night. Take care.
Sure.
Goodbye. I hope you
Bye.
learned something, and if you have any doubts, ask me later. Fine. Fine.
Yeah. Thank you. Bye.
Safa, Zahra, can you hear me?